Okay, so what are things we have seen? Let's once again we'll see, and today we'll complete optical instruments. Optical instruments, there are only two instruments, so I've already written the things so that we can directly go through this. So lenses, what are lenses? Just quickly we'll see. We'll derive the formulas if required once again, and so what are things we have seen? Just one second. Okay. So let's say basically double refracting surfaces, both are generally we take them as spherical surfaces. So when we are applying two times spherical refraction formula, this is what we are getting. So we have how many types of lenses here? Biconvex, biconcave, planar convex, all these things we have seen. So what are we and finally we have two types of lenses. One is a convex lens. Basically it is what kind of lens it is going to do is it is converging, and this is a concave lens. What it is doing here? Dimension, right? And then so the distance, so basically when the light is sent, when a parallel beam is sent, what is the thing is happening is that the rays are meeting at this point. This is the point where light is meeting. So this is a focus, and it is actually forming a real image here. Whenever we put an object in infinity, the image is formed at the focus. And so for lenses, we call the center of the lens as optical center. Whenever the light passing to the optical center, it goes undeviated. This is one key point we have to remember. And what are the formulas we have derived? That is the lens maker's formula. What is lens maker's formula? We have written 1 by f is equal to what? Mu2 by mu1 minus 1 by r1 minus 1 by r2. So if this is air, if the lens is surrounded by air, then what will happen here?
Mu minus 1 into 1 by r minus 1 by r.
Minus 1 into, this is what will be coming out, and this is the lens. And here whenever you're using the formula, what does this symbol means?
Sine, sir.
So we have to apply the sign convention. Without sign convention, we should not use this formula. If you're not applying the circulation filter, not to use it all, because you'll get unnecessarily negative marks. Okay. So and once more we'll see this part. That is where you place the object will decide what kind of image will be. So just zoom out this. Okay. So if the object is at infinity, where the image is formed?
Focus.
Focus. So what kind of image it is? Real, inverted. Whenever the image is real, it is going to be inverted, and when the object is placed infinity, since it is a point size, is a diminution point size we can say. And total how many regions we have is from beyond 2f, between 2f and f to optical center. If you place the object beyond 2f, place the object beyond 2f, where the image is formed. So here whenever we are drawing the diagram, we need two rays. What are the two rays are? We can take one ray parallel. When you take the ray parallel, after passing through the lens, it should pass through focus. This is one ray we can take it. And what is another ray that we can take it? If the ray is passing to the optical center, how does it go? It goes undeviated. Just to draw two rays, and where these two rays meet, that is a point where the image is going to form. Just we'll take these two rays only. We'll be always be drawing the ray diagram in this map. So you don't have any confusion drawing the ray diagram, right? So just we'll see the things once again here, and then we'll start our optical instruments, because optical instruments also will be using two lenses. So if we are using the two lenses, then we can find how the final image will be formed by using the two lenses. So just quickly, if you'll see this part, when the object is placed beyond 2f, the image is formed where? Between f and 2f. And so it is real, inverted, and diminished it is formed. If you place the object at 2f, image is formed at 2f only. And what is the nature? It is of same size, real and inverted. And now if you are in between, 2f and f, between 2f and f, image is going beyond 2f, and it is magnified. It is enlarged, image is formed. And if you place the object at focus, where the image is going to be, it formed at infinity, and we cannot exactly say whether it is real or virtual. If it is placed, now this is where we are going to focus in the optical instruments as well. So what is the specialty here is, if you place the object between F and O. If you place the object between F and O, now what is the thing is happening? If you take the light ray parallel, it is passing through focus, and the ray passing through optical center, it goes. Now they are not going to meet. If they're not going to meet, what do you have to do? We have to trace it backwards. If we trace it backwards, yes, they are appearing to be meeting the back. That is, a virtual image is formed. It is erect, and one more thing, it is enlarged. So if you want to find virtual magnification, where the object has to be placed, only one place we can, that is only one place we can put, that is between F and O in case of convex lens. And finally, only one case is there for concave lens. But what does a concave lens will do? It always forms virtual, erect, and diminished. So wherever you place the object, it always forms virtual, erect, and diminished images. Right? So again, how we are drawing the diagram? We take the ray passing parallelly, then what is happening here? It is getting diverged. And if you take another ray, so it is going undeviated. So they're not going to meet. So if you trace it backwards, they're appearing to meet, and it's a virtual image, erect and very small, diminished it is formed. So these diagram parts understood, where you put, where it is going to form. Right? So this is, yesterday also we are done in the class. Once again, we are seeing it. So very important. So, and next is the power of a lens. If you take one lens, what is the power? It is equal to 1 by F, and here the focal length should take it in meters. When the focal length is 1 meter, then power is 1 diopter. Or else if you take in centimeters, it is also what? 100 by F if you take it in centimeters. Okay. So power of converging lens is positive, power of diverging lens is negative. Okay. And then what is the lens formula? Lens formula, whenever you're using 1 by F, 1 by V is equal to 1 by V minus 1 by U is equal to 1 by F. Again, this comes with conditions applied. That is, you have to apply the sign convention. Only when you apply sign convention, you have to use this formula. And then based upon different U values, then you F value, then you can find V value. Right? There are no doubts in these cases, right? How do we apply the formula? Focal length calculation for the lens and using the lens formula. And next is lateral magnification. Lateral magnification or transverse magnification is simple. If there is a lens, if you put it here, the image is formed here. So if this is height of object, this is height of image. So this magnification factor M is equal to what? Height of image by height of object. How do we calculate the height of these things? V by U. That is what is the magnification factor. And if you want to write it, we can also write it in terms of another forms also. This is equal to V by U. In the place of V, what we can write? 1 by V is equal to 1 by F plus 1 by U. So V is equal to F into U by F plus U. So what is V by U is coming out to be? F by F plus U. So M can also be written in this form as well. M can be written as F by F plus U plus F also. Then if you want to write in terms of, so again, no need to remember these things. Just remember one relation, and then you substitute the things, you'll be getting the answers. Right? So these three are basics. What are the three basic things? Are 1 by lens formula mu minus 1 into 1 by R1 minus 1 by R2. That is the first lens makers formula. And 1 by V minus 1 by U is equal to 1 by F is a lens formula. M is equal to, that is height of image by height of object is equal to V by U. So these are the basic things. So if you apply these three things properly, then you can do anything. All the questions can be done in this manner. So there is a method. So this is what we have not covered. So we'll come back to this once. So there's a method called lens displacement method. We'll cover it today. There's just two things we haven't covered yet. One is lens displacement method we haven't covered. This part we'll see it. And also one more thing is Newton's form. The Newton's formula also we'll see. And also we'll complete optical instruments today. So these two things we have to see, and also optical instruments we'll cover. We'll come back to this. So, but we have seen when the lens are in contact. What is the effective focal length? How to find out the effective power? How to find? So when the lens are in contact, so what did he said? So if this is power is P1, this is power is P2. Then what do you say that effective power is equal to?
P1 plus P2.
P1 plus P2. If there are more are there, then simply keep on adding. Then similarly, the effective focal length is equal to what? 1 by F1 plus 1 by F2 plus 1 by F3 plus so on. And again, when you are using this, you have to be careful with the signs. For convex lens, power is positive. For concave lens, the power is negative. Okay. And if you want to find total magnification, so each lens is going to produce its own magnification. If you want to find total magnification, what you have to do, just multiply them. So we have to multiply them to get the total magnification. Each lens, because what is going to happen if there is an object due to the first lens, it forms first image. Lens 1 will create first image. Then again, lens 2 will create second image, and it keeps on going. So here there is one magnification factor, here there is another magnification factor, and here in this way. So the total magnification factor, how do we get it, is just multiply them. Okay. So this is when the lens are in contact here. When the lens are in contact, directly add the powers P1 plus P2 plus P3 so on. But if the lens are not in contact, if they are separated by some distance, so we are not deriving this formula. Just you have to remember this. So 1 by F effective is equal to, here it is written, that is 1 by F1 plus 1 by F2 minus D by F1 F2 it is. So this formula, again, if you want, we can derive it, just it will take some time, but it is not necessary. It is not necessary for us to derive here. Just you have to know, just when the lens are separated by some distance, so the effective focal length, there is a D part also will be coming out here. Only this is only to be used only to calculate effective focal length. Don't use this formula to calculate image distance here. Okay, this is only to use effective focal length. What I'm saying is that if they give two lenses and if the separation between them, if it is given, then use this formula to get the effective focal length. But if they say this is one lens is there, this another lens is there, if object is kept here, if you're seeing from this side where the image is going to form, then you cannot use this formula. You cannot use this formula. You cannot say this is U and you will take this is F. You cannot do it. What you have to do here? If this F1 is given, if this F2 is given, if this is D is given, then how do you find the image distance? First, due to lens 1, you have to apply lens formula once. That is 1 by V minus 1 by U is equal to 1 by F. You have to use this. Get the image 1 location and measure its distance. Like for example, if it is forming here, then you find this distance and say this is U2. Getting it? If this is object, if this is image 1, if it is formed here, and say this is the distance U2, and then again for lens 2, you apply the formula once again. What is that? 1 by V, again 1 by, here U1, V1, here U2, V2 is equal to 1 by F1, 1 by F2. You'll get the final image location in this part. Understanding?
Yes, sir.
Okay. So if they ask to find effective focal length, use that formula. But if they ask to find the final image location, then you have to use individually lens formula and you have to find. Okay. So and also yesterday we have seen, okay, just we are not silvered lens part. Silvered lens part, what is the thing we have seen? So when the light is incident on the silvered lens, first it has to go through lens, then hit the mirror, then again it has to go through lens. So in that case, we said the effective power, the total power is equal to what? 2 times power of lens plus 1 time power of mirror. In the case of power of lens, what you have to substitute? In case of power of lens, you have to substitute what? Again, I'm writing here the formula. So in the case of silvered lens, so what it is? 1 by, there is first power formula is what? Total power or the effective power is equal to 2 times power of lens plus 1 time power of mirror. So 2 times power of lens, if you want to write this focal length of lens, you should write. Then in the case of power of mirror, what we have to write? Minus 1 by Fm, right? And here overall, even though it is a silver lens, it is going to behave like a mirror only. So for mirror, power is what? 1 by the focal length of the silver lens we have to use. Isn't it? Remember this relation yesterday we have seen. Following?
Yes, sir.
Okay. Right. So next, silver lens part we have seen, and then comes optical instruments. Okay, let us complete first this. Okay, lens displacement method. The Newton's formula first. I'll write the formula. So what is the formula here? The Newton's formula says that. So Newton, again, he belonged to what, 300, 400 years back, right? So he has given. He also calculated the focal length for mirror. Also he calculated focal length for lens is calculated. But so he did in different manner. So what is the difference he has done is just writing first Newton formula. For example, if you take a lens, what are the things you're having? It has a focus one side, it has the focus on other side. If you take object here, so he, instead of measuring the distance from the optical center, he measured the distance from focus. He said that is a distance measured from the focus he measured, and then image which is formed here. Image is formed here. Again, he measured distance from focus only on this side. So object and image distance he measured from focus only. And when he measured and he got that focal length is equal to under root of x1, x2 he got. So what is the Newton's formula? And it is helpful to calculate. If you know, if object is placed at a distance of x1, if image is formed at a distance of x2, if the distance are measured from the focus, the relation between the object and image distance is given by f is equal to under root of x1, x2. Okay, should we derive this?
Yes, sir.
Okay, so what is the formula we are having? So normally what we say, this is u, right? This is actually, now we should say f, u is equal to what? U is equal to f plus x1, should you write it? Then what is v is equal to f plus x2, we can write it. Now if you substitute this in the normal lens formula, what is the lens formula is? So lens formula, so 1 by v, but in the place of 1 by v, can write 1 by f plus x2. Then minus 1 by minus of f plus x1, right? Is equal to what? 1 by f it is. Now just we have to solve. These things and we'll be getting the things. So if you're solving this, how do you solve? You can write it. So 1 by f plus x2 is equal to, this is minus into minus become plus 1 by f plus, if it comes this side becomes minus f plus x1. So 1 by f plus x2 is equal to f plus x1 minus f by f into f plus x1. F got cancelled. Then if you're solving it, f, I'm sending this on this side, becomes f square plus fx1 is equal to, if I'm sending this on this side, f into x1 plus x1 x2. So fx1 got cancelled. What are the things you're getting? F is equal to under root of x1 x2. Understood?
Yes, sir.
Okay, directly you can use this as a formula. So whenever they say if object is placed at a distance of, like there is a standard question everywhere, it is a, like they will say that object is placed at a distance of 5 centimeters from focus, and image is formed at a distance of 20 centimeters from focus, then what is the focal length? Then f is equal to what? What is it? F is equal to, this is x1 itself and this is x2 itself. So what is x1 is 5 and x2 is 20. So answer will be 10 centimeters. Like that, they'll be asked. Understood?
Yes, sir.
Okay. Right. So next, so this is a one thing which we have missed yesterday. And one more thing is lens displacement method. So I'll write it lens displacement method here. So again, what is the purpose of these two? Even the Newton's formula is there to find focal length only, and even the lens displacement method also is there to find the focal length. So what is the specialty of the convex lens is that it can form real image, right? So if the screen is placed here, what we can do is that if an object is, if you fix the object, okay, I'll fix the object here. Now I'll take the lens. If you put a lens here, now for this distance, this is the lens position. This is lens position 1. For this position 1, so what is the possibility is that for this u, then for this u, then image can be captured, right? So just an example. So for example, you are adjusting the screen. So initially you fix the object position. Then you adjusted the screen so that you can capture the image here. Image is formed over on the screen here. So that is real image is formed. So this is the first position at which it is formed. Now, what is the thing is that, so we know that, so when the object is placed beyond 2f, image is formed between f and 2f, right? That is
Yes,
when
sir.
you interchange, what is the thing? What is the other possibility is that, so if you move the lens, to the new position, so if you move the new position, lens is moved to position 2. So again, you will be able to capture the image once again. There are two positions. There are two positions for the lens for which we can capture the image. So first position of lens is here, second position of lens is here. So what is the thing is happening is that, so actually we can also verify by using the formula. That is, for example, if f is equal to 20 centimeters, if u is equal to 15 centimeters, we calculate what is v will be coming out. So let us do it. 1 by v minus 15 is equal to 1 by 20. So what will be coming out here? So 1 by v is equal to that is 1 by 20 minus 1 by 15. That is 1 by 60 it is coming, isn't it? You'll be getting v is equal to 60 centimeters. Now, if f is equal to same 20 centimeters only, if u is equal to 60 centimeters, then what do you think v value will be coming out? So again,
15 centimeters.
It will come 15 centimeters. That means now when you exchange the positions, that means, so when u becomes v becomes u, it is what it is going to happen. That means there are two distances at which image can be captured on the screen. So that is what is the basic principle here. So basically, what is the thing we are doing in the lens displacement method is that we are fixing the object position, we are fixing the screen position, and what is the thing which we are moving here? The thing which is moved here is a lens. So if this distance is what we are calling it as a d can be written as u plus v, right? This is u and this is v. So u plus v can be written as d here. So this is the object to image distance. Now this distance is what? Initially this is u. Now this became v. Now this becomes u, right? Can I say in this manner? The positions are exchanged. So when u becomes v becomes u. This is still the image is formed here only. Understanding the things here?
Yes, sir.
Okay. So this gap is what actually is the distance the lens has been shifted. So the distance the lens has shifted. How much is the distance, can we say? So this part is v. This part is v. If this part is u, so this part must be how much?
V minus U.
V minus. That's so now what we can write? So capital D is the distance between object to the screen, and small d is actually the distance the lens has been shifted. So d is equal to what? V minus u. Now from this we can get what is v and u value. For example, if we add these two, what will happen? D plus d by 2 is equal to what? U gets cancelled. That is a v. I'm adding and I'm sending. Okay, one more step already. D plus d is equal to 2v. What is v is coming out to be? D plus d by 2 is coming. Now if you substitute this v in here, you'll get u value. U will be coming out to be d minus d by 2 will be coming. Now when you know both u and v, can we get the focal length? 1 by f is equal to 1 by v minus of. So that is you substitute it. So what will the things we'll be getting is that, just let us substitute and proceed. Then we'll be getting the focal length. 1 by, this is 1 by d plus d, and this 2 will go to numerator. Minus becomes plus. So d minus d by 2 will go to numerator. So what will be coming out? So 2 in the numerator top. So d minus d, LCM we are doing d plus d by d square minus small d square. Then small d got cancelled. Then what will be coming out? F is equal to d square minus d square divided by d, and d becomes 2d, and one more 2 is there, becomes 4d. So this is a focal length formula in the lens displacement method. In the lens displacement method, what is capital D here? Capital D is a distance between object to screen. The distance is capital D, and small d is a distance, the distance between the two positions of lens. The lens has been displaced by small d. That is why it is called as lens displacement method. It is. Okay. Understood?
Yes.
Okay, this is it. And so here, 2 times image is found, right? 2 times image is found. That is for the first position. For the first position, what is the magnification produced? When the lens is position 1, magnification m1 is equal to, it is a image distance is v, object distance is u. So v by u is. In the second time, the image distance is u, object distance is v. So what is coming out? M1 into M2 is equal to what? M1 into M2 is equal to, then it is coming out to be what? V by u into u by v. So it is getting, that is u get cancelled, v get cancelled. M1 into M2 is equal to 1. M1 is height of image 1 by height of object. M2 is height of image 2 by height of object is equal to 1. That is height of object square is equal to height of image 1 into height of image 2. So height of object is equal to under root of h1 h2. This is also one more formula in this topic. So there are only two formulas here. There are two formulas here. One formula is a focal length formula. That is capital D square minus small d square by 4d is a focal length obtained by using the lens displacement method. And other formula is height of object is equal to under root of height of image 1 into height of image 2. Yes. Okay. Right? Understood?
Yes, sir.
Right.
Yes, sir.
This is it. And this is about the lens and this lens displacement method. Okay. So in the lens displacement method, and one more condition here is that the distance, if you want image to be captured, then the minimum distance between the object and the screen should be d should be greater than 4f. So why? Because we want two positions, right? If you want two positions, then what is the thing should happen is that when the object is at 2f, the image is also at 2f. So the minimum distance between object and image should be 2f this side and 2f this side. That's why it becomes 4f. Then only we can capture two images, or else we cannot capture two images. The least distance between them is object and image is 4f. So that is what we have to make sure. So D must be the condition. The condition for the lens displacement method to work, D should be greater than 4f here. And the formula is, here they are saying this is actually we took it as small d, and this is capital D. So the capital D square minus small d square by 4d is a focal length. And the magnifications, when you multiply, it is m1 into m2 is equal to 1. And height of object is equal to what? Root of height of image 1 into root of, that is image 2. Yes. Okay, so done. Now the lens, can you say it is done better?
Yes, sir.
Okay, so this is it. Lenses, cases, finding the combination of lenses, and silver lens. Now, if you go for optical instruments, so yesterday we have seen a little bit about the defects in eye. We'll again come back to this. Let us directly go for optical instruments first. So optical instruments. So why do we need optical instruments when we have a natural optical instrument, that is eye? So human eye is also an optical instrument. It is helping us to visualize the things. We're able to see the things because of the eye. But what is the thing is that the range is limited. We cannot see the things. If we are seeing, we can only see the things which are of millimeters in size. If their things are in micrometers, nanometers, atoms, we can't see them. The range is limited. If you want to extend this range, if you want to see the planets, if you want to see the stars, if you want to see the moon in a better view, so we want to use, if you want to see far distances, we need telescopes. If you want to see the things, small things bigger in size, we need microscopes. So we need optical instruments to see smaller things like microbes. If you want to see, we need a microscope. So basically, the objects, they have their own size, but they appear bigger or small. If you want to see the size bigger or small, for example, if you are seeing, we are seeing this object which is speaker is. If this object is, we are seeing, if it is far, it appears small. But as it comes closer and closer, so what is the thing is appearing? It appears as if it is becoming bigger and bigger, right? So the size is not changing. The size of object is same, but it appears bigger or it appears smaller. The only thing depends upon is how far or near it is. If it is far, it appears small. If it is near, it appears bigger. So if you want to make the size big, just try to visualize it near. If you're able to bring it near, then what is the thing is going to happen? It appears bigger. That is what the optical instruments are going to do. They are going to bring the objects, or they will form the images near. They'll do the magnification and as well as, but they'll also make sure that it will make them appear near. That's what the optical instruments will do. So what is the simple thing? Our the object is when it is near, it appears big, and vice versa. That is, if it is far, it appears small. So eye sees the objects and its size is based upon the angle. So an angle it projects. If you take the same object, if it is near, it projects more angle. So more angle, it appears bigger. If it is far, it's obtained very small angle, so it appears small. So now for more magnification, what we can do is that we can bring the object, or we can bring the object or image closer. Any one of them, we should bring them closer, then we can see the things clearly. But it's not like we can bring as near as possible. If you bring the object near and near and near, so what happens? It becomes blur. We cannot see the things clearly. There is a least distance of distinct vision or clear vision. So for normal human eye, what is the least distance of distinct vision is 25 centimeters. Okay, you have to remember this value, capital D. Whenever you see capital D, so in this, don't think that in the lens displacement method that capital D and this capital D are different. Here we are talking about a normal human eye, and the least distance of distinct vision or clear vision is 25 centimeters. Lesser than 25 centimeters, what happens is that the vision will not be clear, it becomes blur. You are trying to see your hand by keeping it very close, you cannot be able to see clearly. The eye will be strained as well. When you are trying to keep the book and try to read by keeping it very near, your eyes will be strained. So you have to keep at least some distance, like 25-30 centimeters is recommended distance. That is where the actual clear vision begins. Okay, so there is if the distance is limit is there, that means there is a limit for angle also. For direct viewing, there is a limit for angle. So to increase this magnification, that is, if you want to increase this angle, so we need these microscopes or telescopes. Understanding why do we need microscopes and telescopes? Just to increase this angle, objects or images going to subtract. Understood? Now we will be only be talking in terms of angles only. That's why this all explanation is for. Following?
Yes, sir.
Okay. So what is the thing we are seeing next? So now what is a simple microscope? Is there for simple microscope nothing but a magnifying glass. Magnifying glass is a simple microscope part. Okay. So what is the thing we are saying is that without microscope, now just this object is there, you want to see with the eye, directly you are viewing it. So what is the nearest distance that you can put it is 25 centimeters. We can put the object, the least distance where you can put it is 25 centimeters. When you bring as close as possible, the angle is maximum. So the maximum angle the object can subtend is what we are saying it as. Like this is forming like a rectangle triangle. Tan theta is equal to opposite by adjacent. For small angles, tan theta is approximately theta. So theta naught is equal to height of object by d. D is the least distance of distant vision. The object should be kept at least 20 centimeters for clear viewing. Okay. Now we are taking the simple microscope is basically convex lens. It's also magnifying glass. Now we want magnification. If you want magnification, and so where you have to put the object, you have to put the object between F and O. Then it forms image what? Virtual, erect, and magnified image. That's it. You keep the object between F and O. So how the image will be formed? What do you have to do here? You should draw ray diagram. How do you draw ray diagram? You should take the parallel ray. So this is the focus here. After the refraction, double refraction passes through this, and the ray which is passing through optical center goes undeviated. They are not going to meet. If they're not going to meet, what do you have to do?
Extend them backwards.
Place it backwards, and then they are appearing to meet. So this is where the image is appearing to be formed. This is where the image is formed here. Image, and this is where object. So now, so this is theta. The object is subtending. This is u. So even the image is also subtending the angle theta. So now, what is the How do we measure? Here we do not measure lateral magnification or long-term magnification. Instead, we will measure angular magnification. For instruments, we measure angular magnification. So what is angular magnification? It is an angle subtended by the image. It is an angle subtended by image. So for example, if person is seeing here, so on the person, what is angle? These are small angles. So angle subtended by image divided by angle subtended by object without the optical instrument. Without the optical instrument means what? So that is without the optical instrument, what is angle subtending? We are saying theta naught. So what are the two things we are dividing now? So m is equal to the theta by theta naught we are dividing. Understanding?
Yes, sir.
Yes,
Okay.
sir.
Now for clear viewing, the image should at least form at what distance? This should be 25 centimeters, right? If you want to see the image, then the distance should be, I will be generally very close. I will be close of here, close only, it's not going to be that far. So for clear viewing, so the distance, the image distance is at least, this is what. So what is the thing is coming out here? So this is height of object. This is height of image. So how do you find this angle theta? So tan theta, we are writing, either we can write height of image by d we can write, or we can also write height of object by u also we can write, isn't it? Because this is one triangle and this is another triangle. So both are the same straight line going undeviated. That's why we are taking this one. So what is angular magnification coming out? So theta is coming out to what? Theta is coming out to be height of object by u. It is coming, right? So theta is equal to what? Height of object by u. And what is theta naught is? Theta naught already we calculated. What is theta naught is coming out to be? Height of object by d it is. So that is ho by d it is. So ho by d. Anything getting cancelled? H naught, that is height of got cancelled. So what is the magnification produces? D by u it is. So due to the magnifying glass or simple microscope, what is the magnification it is going to produce is d by u. Now you can change. You can change u, and as you change u, magnification will change. But the image should be formed where? Image, if you want to see this image, can be formed the distance, and there are two things here. If the image is formed very far, then I will be relaxed. I can see the things relaxedly. That is we call relaxed eye magnification. If the image is formed near, the near means at near point. That is where distance and where the image is formed. So that is where image is v is equal to d here. Here v is equal to infinity. So when the image is formed at near point, eye will be strained. So that is what we call as strained eye magnification. So relaxed eye magnification is how much? And strained eye magnification is how much we want to find. Following the things here. First of all, what is the magnification produced by simple microscope is d by u we are saying. Now this magnification can be varied. It depends upon where the image is formed. So for relaxed eye, so where the image should be formed, we are saying. Image is formed at infinity. It can form far. Image should form at infinity means you should be what? At focal length, right? We have to place the object at focus. To place object at focus, and magnification is coming out what? D by f. Can we say in this manner? Following?
Yes, sir.
So for strained eye, image should be formed where? Image should be formed at least at the distance d. When you know v is equal to d, or actually v is equal to minus d if you take it, then we want to find u. How do you find u? We have to apply again Lenz's formula. That is 1 by v. That is in the place of 1 by v can write minus this. Then minus becomes plus is equal to 1 by f. So what is coming out to be 1 by u is equal to what? 1 by f plus 1 by d. So now we are looking for magnification. So what is magnification is going to be coming out here? The strained eye magnification. I'll erase this part. When you put u is equal to what is coming out, and the image is formed at when v is equal to minus d. So 1 by u is equal to what? 1 by f plus 1 by d. So what is magnification is equal to d by u, that is 1 by f plus 1 by d. So when you multiply these things, what it is coming out? M is equal to what? Huh? D by f plus 1. That's it. These are the two formulas we are having. In the case of simple microscope, it can produce magnification. Can produce magnification of d by f. When it is going to produce magnification of d by f? When eye is relaxed. When you want to see the things relaxedly, magnification is little bit less. They'll see the things very clearly. Easily they'll be asking. They'll say that using the lens of 5 centimeters, what is the magnification you can produce? So since d value is how much? D value is how much? Hmm?
25.
20?
25 centimeters.
D is equal to 25. So 25 by 5, if you take it, what is the magnification is coming out to be? 5 times. Right? And that is in the case of relaxed eye. For a strained eye case, what is going to happen? Plus 1 times. So that means, so first for the relaxed eye, the magnification is 5 times. Then for the strained eye, the magnification is 6 times. That's what directly questions will be asked in this manner. Nothing else will be asked. So for simple microscope means nothing but a single convex lens. When the object is placed between F and O, it forms virtual, erect, and magnified image. How many times magnification it can produce? It depends upon where the image is formed. So when the image is formed at infinity, the magnification is d by f. When the image is formed at a near point, then the eye is strained. The strained eye magnification is 1 plus d by f it is. Is it clear?
Yes, sir.
Okay, this is it. This is simple microscope it is. And then we can go for, so here in a simple microscope, if the focal length is like 5 centimeters, then magnification only coming out to be 5 times or 6 times. So 5 times, 6 times, is it sufficient?
No, sir.
5 times 6 times is not sufficient. You want more magnification. So for more magnification, for greater magnification, simple microscope is not sufficient. That's why we are taking two convex lenses. So both will magnify. When both magnify, then there will be more times magnification will become. So basically, we'll take two convex lenses, we'll put it in a tube, and that is a sliding tube where we can move the lenses here and there. When we move the lenses here and there, so the distance between the lenses can be varied. If distance is varying, then automatically the magnification can be varied as well. So there are two lenses here. There are two lenses here. The lens which is near the object, which is facing the object, that's the objective lens we call. And the characteristic is that it should be having the short focal length and it should have smaller aperture. So smaller aperture means the vertical diameter should be small. And if you take the lens which is near to the eye, that is what we call it as eyepiece. Eyepiece also should be having shorter focal length, but it should be more than objective lens. So two lenses, we need both the lenses shorter so that because the magnification, all these things is for magnification. If you want more magnification, then here, so we'll be seeing that formulas will be coming. The formula says that, okay, you see the formula. You see the formula is focal length is in denominator. The focal length is a denominator, so it should be smaller. Then only more magnification will be coming. That's it. So again, here also, just we are taking two lenses. Two lenses will do their job and will produce a final magnification. How much will derive that part? Simple things only. Again, derivation is not required. If you remember the formula also, it's enough. Okay. So for the lens which is near to object is objective lens. The lens which is near to eye is eyepiece. One is at the object side, objective lens. Eye side is eyepiece. Okay. Then, so first of all, objective lens. So if you see here, what is the thing we are doing is that we are taking the lenses. So what this is smaller in size, this is bigger in size. This is what having smaller aperture and bigger aperture. And then this will have objective lens will have focal length of FO and eyepiece will have the focal length of FE. So FO is smaller than FE it is. That is what we have to make sure. And then, so first object is placed beyond focal length. Beyond focal length, if you put, it forms a real, erect and magnified image, right? So how do we draw the diagram here? First, the ray you take parallel, it passes to the focus, it will pass to the focus, then it is going somewhere like this. So exact diagram. You can show like this. Then another ray is passing through this, and then it is going to meet somewhere over. This is the first image is formed. Okay, it is what the image formed by eyepiece. First object lens is real magnified image is formed, and then that image is going to act like object. That image is going to act like object for eyepiece, and then you see here. Finally, we want to see the virtual image. If you want to see the virtual image, this should be placed between F and O only. If it is between F and O only, then it is going to again magnify the things, and finally the image will be formed here. Understanding? So first object form the image. That image is going to act like object and forms the final image here.
Yes.
Okay. So this distance is again UE. That is another image is right. VE it is. And so this is UE we can say. And this is a image. So we can say this is as V from object. And this is what we can say is U. So now, what is the length of the microscope? If they say length of the microscope, what is length is coming out to be? It's a distance between the two lenses, that is a VO plus VV. This is the length of microscope. Right? And what is the theta? The final angle is subtended. You measure. This is what we can say. It is a height of H1 by UV also we can say. So now we want to find the angular magnification. So first of all, without any instrument, what is the angle it is subtending is H, height of object by P only. This is the maximum angle it can subtend. Then image is, so again if you want to find for strained eye, final image should be formed where? For strained eye, final image should be formed where? The final image should be formed at least at a distance of 20 centimeters. So this angle, what we can write, this angle theta is equal to, we can write, that is height of the final image by the distance d we can write. And that is what we are taking here. And the dd got cancelled. And h2 by ho it is coming. If I divide and multiply by the h1 and h1, that is height of image 1. Then h2 by h1 is magnification produced by second lens. h1 by ho is magnification produced by first lens. So second lens is just looking like a simple microscope only, right? What is this? Is we forget about this part. It looks like as if there is only one lens. It is doing as if it is a simple microscope. That is second magnification. Based on second magnification, we can write the formula as if it is a simple microscope. What is simple microscope formula is? For strained eye, 1 plus d by FO. That is a eyepiece, right? 1 by FE we can write. And the first one is a first lens is like normal magnification it is producing, that is VO by UE it is. So what is this? It's a magnification of compound microscope. For this is a strained eye magnification. This is a strained eye magnification for compound microscope. For compound microscope, again we have two formulas. For compound microscope, what are the two formulas are? So magnification for the strained eye and for relaxed eye. Again, the two lenses producing their own magnification, that is VO by U into D by F it is. Getting it? So this part becomes D by F, right? For a simple microscope. Just now we have seen the formulas. For relaxed eye, the magnification produced by the lens is D by F. For strained eye, the magnification produces 1 plus D by F. So there are, in the case of compound microscope, there are two lenses. This is producing magnification of MO. This is producing magnification of ME. So MO is equal to what? It is VO by U. ME, it is, if it is strained eye, 1 plus D by FE we are writing. If it is relaxed eye, D by FE we are writing. Then multiply both of them to get the total magnification. Understood?
Yes, sir.
Okay, so direct again formula based formula. And so one more special case here is general case is that normally we take the object very close to the focus of objective. If we take the object very close, then what is the thing will happen is that then U is nearly equal to FO. When U is very near the focus, then image image form will be very, very far. If image is very, very far, that means almost the vivo will be equal to length only. Normally we write what vivo by u. In that place we can write L by F also we can. Sometimes if they use this formula also, directly also we can use to find a approximate magnification formula. Okay. So this is,
Yes.
and finally the image formed by compound microscope is what? It is always going to be inverted only. You see the final image form. How does it look like? If this is the object, you see that this is very big, but it is inverted image only. Compound microscope will always form inverted images. Okay, this is about the compound microscope. So two microscopes, simple microscope. So it is producing two magnification, relaxed dye d by f, and for strained dye 1 plus d by f. For compound microscope, two lenses are there. So each one is producing its own magnification. Finally, magnification is MO into ME it is. And the length of the microscope is VO plus UV. They'll say that object is placed at a distance UO they will give. UO they will give. If they give UO and they'll give FO and FE. So then in that case, once they give this, you can find the distance. And they'll also say the image should be formed far point or near point. If they say far point or near point, that means they will give this distance also. If they give this distance, then you can find UE and you can find VO and you can find this is also will be given. When all these things are given, you can find whatever. Okay, so we'll see the questions like today. If it is not possible, tomorrow we'll see the questions based on direct formula based questions will be asked. And should we go for telescope?
Yes, sir.
Okay, so telescope again, it is what is the purpose is to see distance objects. Distance object, they could be like stars or planets. That is what is the astronomical telescope, to see the far objects like heavenly objects like planets and stars. So when you call that telescope is astronomical one we call. And the ones if you want to see the far distance like far buildings, if you want to see, then that is a terrestrial. Only difference here is that so here in the astronomical telescope we only use two lenses, and here we'll use three lenses. Just now we have seen whenever we are using two lenses, it forms inverted image. But if a person is using the lens, if he's seeing the building, he wants to see the building top should be top, bottom should be bottom only, right? So no, the inversion should not take place. So in order to see the things erect image, in order to see the erect image, so we use a third lens. So that is what we call it as a erecting lens. Erecting lens is used. Extra lens is used to make sure that the top will be top, bottom will be bottom. That is erect image is formed. So in astronomical telescope, what is thing we are doing is that we are using two lenses. We are using two lenses, and again the lens which is facing the object on the object side. That is, if you see, this is what like if you have ever seen a telescope. This is what it looks like. So on this side, one lens will be there. This side, another lens will be there. And if you want, you can move this front and back. So this lens is facing the object. Is object lens. You can see that it is wider. This is wider. That is has larger aperture, and also the focal length is very, very large. Objective lens should be bigger in size and as well should have large focal length. The lens which is near to eye, it is having smaller aperture and also has shorter focal length. So this is what is a basic characteristic of the two lenses which are used in the astronomical telescope here. So the objective lens should be having larger aperture and should have larger focal length. And then, so what is the things are going to happen here? So if you're looking at astronomical telescope, we are saying we're looking at far objects. The rays are almost, they are coming from infinity. Is it coming from infinity? But they'll make small angles. They're making small angle alpha. So with this angle alpha, it is going, and where the image will be formed. This is objective lens. Objective lens has focal length FO. So if the object is at infinity, image will form at focus only, right?
Yes, sir.
And then, so this eyepiece should form magnification. If eyepiece is forming magnification, then the image should be between F and O. So here is FE and here is O. So image is formed between F and O. Then it is going to form virtual magnified image will be formed. That's it. Object is coming from infinity, subtending small angle, image is formed, and that image will be object for the eyepiece, and finally it forms the image. So in this way, finally it is formed. So again, we want to find angular magnification. So finally, what is the angle it is subtending? The image is subtending an angle beta, we are saying, and object is subtending angle alpha. So the ratio is what? Beta by alpha is a magnification factor here. So what is beta is? The beta is opposite by adjacent, and alpha is, we can say alpha from here also, right? Alpha from here. So we are using these two triangles only. This one triangle we are using, this one triangle here. These only have beta. So the common side, opposite side is common for both the triangles. So I1 by FO is cancelling. Then it is what it is coming out. It is coming out to be focal length of FO. FO is what? The focal length of object lens divided by the distance of real image from eyepiece. So this distance is, again, we can say this is U. So this is, okay, this eyepiece, right? This is UE. So finally the formula, the magnification is coming out what? FO by UE it is coming. And for relaxed eye, for relaxed eye, final image should be formed at infinity. The final image should be formed at infinity. Then the object, the distance should be equal to focal length. So what is the magnification for astronomical telescope? Is general formula is FO by UE, but UE is equal to FE in the case of relaxed eye. It's also called as normal adjustment here. In the case of astronomical telescope, if we want the image to be formed at infinity for normal adjustment, this is what the magnification is coming out. It's a ratio of the two focal lengths. Focal length of object to lens divided by focal length of eyepiece it is coming out. And so generally they will not give the directly, they will say the length of the tube, they will say length of the tube. In the case of what is the length it is coming out now? So this part, length of the tube is disturbed in two lenses. This is FO part. Now this is FE part. So FO plus FE is the length of the tube of the telescope. Okay, that is what it is coming out to be. In the case of for astronomical telescope, what is the magnification is coming out to be? FO by UE is a general formula, and for relaxed eye, the magnification is coming out to be FO by FE, and the length is FO plus FE it is coming. Now again for strained eye, final image should be formed where? Near point. Near point means if a image distance is minus d, then how to get object distance? That is 1 by u is equal to, when you send this to this side, this is what is coming out. When you substitute in the place of 1 by u, so this is what is the magnification by astronomical telescope. This is what it is. So total, if we are summarizing the things, I'll write it here. For simple microscope, it has only one lens. Just you have to put, if this is F, you have to put the object here. Then image is found somewhere over here. Then what is the magnification is coming out of it? D by F. For which case? For
Relaxed eye.
and the magnification is equal to what? 1 plus D by F. This is for
Trained.
Okay. Then for compound microscope, we are having two lenses. Object lens smaller and the eyepiece is bigger. So you are placing the object beyond F, so it forms image, and then again it forms a virtual image. Then finally it forms virtual rectangle here. Finally the image, because of the this is producing, this is objective, this is eyepiece, this is MO and this is ME. What is MO is equal to, we are saying VO by U, and ME is equal to what? For relaxed eye, D by FE. For strained eye, 1 plus D by FE. Then overall, what is magnification? For relaxed eye, what is magnification? Just multiply them. MO into ME. So M is coming out to what? VO by U into D by FE it is coming. Then for strained eye, what is magnification is coming out to? For strained eye, M is equal to VO by UO into 1 plus D by FE it is coming. Isn't it? And length of the microscope, if they ask, it is what? It is VO plus UV. Right? This is what is a compound microscope. And last we have seen is a astronomical telescope. In astronomical telescope also, how many lenses we have?
2.
We have 2 lenses. If you're having 2 lenses, so but objective lens is big and eyepiece is small. The rays are coming, it is falling. First, the image is formed at focus, and then it is forming. It is going to form the virtual image bigger. So this is alpha, and this is beta. Magnification is coming out what? F. This Fe by or FO by UV. It is what is coming out. And again, for relaxed eye, image should be formed at infinity. So the distance from eyepiece, so M should be FO by FE. And length is coming out to be length is equal to FO plus FE. It is the case of relaxed eye. This is also called as normal adjustment. This is also called as normal adjustment in the case of telescope. And other case, it is FO into 1 plus. This is what it is coming. Okay, so this is FO and this is UV. So length is FO plus UV in general case, but in the case of normal adjustment, UV is equal to FE. It is. This is astronomical telescope. It is. Okay, understood optical instruments. Only 3 optical instruments are there: simple microscope, compound microscope, and astronomical telescope. It is. Is it clear? And just we'll make a small adjustment to make it terrestrial. Only thing we have to do is that we don't want inverted image. So we have to correct it. We have to make it erect. How to make it erect is just add one more lens. First, this is the objective lens. What is the things happening? It is forming. It is forming image. This is objective lens. It is forming a distance of FO. Then what is the thing you have to do is that you have to make it erect. How to make it erect? You put a small lens so that if the focal length is F, when this distance is 2F, what is going to happen? What is this lens is going to do? It is going to again form the image at 2F only, right? So this is what we call as erecting lens. Its only job is to make it erect. So this got inverted. So if you want to make the erect again, we need a lens. If you place the distance is 2F, then again it is going to form the image at 2F. And now you put the eyepiece. Then again it is going to form virtual magnification. So this will be again UE only. So then here the length is again for normal adjustment. UE is equal to FE. Then length is equal to what? FO plus 2F is what? 4F plus FE. So this is in the between, the F is the focal length of erecting lens. It is. Magnification formula is same. Magnification formula is same as astronomical telescope only. Understood? Okay.
Yes, sir.
Yes, sir.
Okay. So this is it. The topic. Optical instruments. Total 4 instruments, 2 microscopes, and 2 telescopes, and their respective magnification formulas. Right. So, and yesterday's what is the thing we have done is the defects in eye. Like what are the defects you have seen? Myopia is short-sightedness. Normally, the rays should incident on retina, but for short-sighted people, the rays are unable to converge. They are converging in front of retina. So we need a correcting lens. So for example, if you use a diverging lens, it is going to help it able to form the rays will diverge and finally it will form a retina. So the correcting lens. So what is the focal length? We said yesterday 1 by F is equal to. There is a simple like formula. It's not going to be given in the book. They will say that a person with some defect, he wants to see this distance instead of this distance. So what is the formula you can use it is what he wants to see minus that is 1 by what he can see. What he can see. So this, if you are using this as formula, you can only recommend the focal length for the respective like correction. Even for both myopia also same formula, for hypermetropia also same formula. Okay, like they will say for, let us take an example for myopia, the person, the far point is, for example, he can only see up to 1 meters. Far point is a person only able to see up to 1 meter, but he wants to see like 4 meters. He wants to see clear. Okay. So in that case, what he'll say, the recommended focal length is 1 by what he wants to see is 1 by 4 minus 1 by 1. That is 1 by what is this? Minus 3 by 4.
3 by.
So if you say power is equal to this is minus 0.75 diopter you recommend. Or if the person says I want to see infinity, the person says infinity means then what is the thing you have to recommend here is the power is equal to 1 by f is equal to 1 by infinity minus 1. That is minus 1 diopter you have to recommend. That's it. For hypermetropia, what is the thing? Is that the near point? The near point, for example, the person is not able to see 25 centimeters. Instead, he is only able to see 1 meter. So he can see is 1 meter. Now he wants to see is like 25 centimeters. He want to see like a normal person. So what he can see, what he want to see, these are the two things. That is 1 by f is equal to what? So if here, this is if you are writing in meters, if you are writing directly, that is 0.25, and this is 1 meter. That is what it is. So 4 minus 1 is 3. So power is equal to what? You should remember plus 3 diopter power like that. Understood?
Yes, sir.
Yeah.
Okay. Then again, no new formulas. And presbyopia. What is presbyopia is when the person is suffering from both. Presbyopia when that is happens generally in the old age people where it is written, yes. So basically just a little bit you know the things, right? Because I think you studied very all these things, you know the names also, I guess. What is the thing which requires? This is a lens part, which is a convex lens, and so this is a ciliary muscles. Ciliary muscles are the ones. So like whenever you like we know that when you enter into the dark room, our eyes will open up. And whenever you enter into the bright room, then eyes will, so that's opening and closing part will be there, and as well as so to just to focus, there are two things here. If you want to see at a time only one thing we can focus. We are seeing the near one, the background appears blur. If you are seeing the background, the front will appear blur. So this is the change in focal length. The change in focal length is able to be done with the help of ciliary muscles. So ciliary muscles helps in focusing of the eye. So it can change the focal length to see the things. Sharp imaging can occur, and the tension in the ciliary muscles will, like when we are stretching and when they are relaxing, so then the focal length will change. This property of changing focal length of eye is called as accommodation. What is accommodation of eye means? The ability to change the focal length to focus at different distances at time. Ability to focus at different distances at a time is by changing the focal length of eye lens is accommodation of eye. It is a theoretical question they can ask, and it is as long as ciliary muscles are healthy, then eye will be able to focus at different distances. But if they get strained too much, then the eye may lose its accommodation. Then only the requirement of lenses eye, that is what will be coming. So when as old age comes, that is a defect in the eye will be presbyopia. That is where the person is unable to see both near distance and as well as far distance. The person is unable to see. That is a presbyopia, where for the presbyopia people you have to recommend bifocal lens. Bifocal means you have to have concave lens to see far point for far point adjustment, and you need a convex lens, the converging lens, to see the near point adjustment. So generally concave lens is for myopia people, myopic eye we say. For convex lens is for hypermetropia. But when the person is having presbyopia, both should be recommended. Okay. So this is, and one more defect in eye is called as astigmatism. Astigmatism is cornea should be in spherical in shape. If there is any damage happens to the cornea, the curvature of the cornea becomes deformed. If a non-uniform curvature of cornea is there, means it is not able to see the straight lines. Straight lines will not be able to be focused properly. Instead, they will appear like a curve shape. You see that this is a straight lines they are, but when you are seeing, when they are forming on the eye, they are becoming curved. So astigmatism is due to the non-uniform curvature of cornea. So how do we correct this? We have to use a cylindrical lens. Cylindrical lens means they'll show it here. So like this. So there is a cylindrical curvature is required. So cylindrical curvature will help. So that is why if you see the eye lenses, someone will wear the straight, but someone will have cylindrical part of the lens. So that is to correct the astigmatism. That is a deformed. The cornea is deformed in that shape. So these are the 4 defects. What are the 4 defects are? Myopia, hypermetropia, presbyopia, and astigmatism. And so how do we correct these? For myopia, we have to use diverging lens, that is a concave lens. For hypermetropia, we have to use a convex lens. For presbyopia, we have to use bifocal lens. For astigmatism, we have to use cylindrical lens. Understood?
Yes, sir.
Yes, sir.
Yes.
Okay then. So this is it. So shall we stop it here? Tomorrow we can discuss the doubts, or if there are any doubts are there, you can tell. Then we'll see it if possible.